Previously on The Bald Engineer.
Really? If it's fixed, then we fixed it. Yeah. What? Thank you so much. Woot indeed. Hello, 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 hello. How is everybody doing tonight? Happy Thursday, the first Thursday and the first day of the second month of the 2024th year. Oh, I did it. I started saying all those words before I knew whether or not I'd be able to finish. How is everyone doing? All right, let's get this pinned up. Hey, Bellum, good to see you. Hey, Jack, welcome back. All right, so let's put that there. That should be good there. And then, yeah, that should work out. Okay, and then we're going to pull up something over here. Yep. So, yeah, so actually, funny story. We almost were in the lab today, but I haven't turned the streaming computers on in over a year. And so I realized that that was not going to work out. Thursday. Oh, goodness. Although I do remember like 20 years ago when I used to go to the bars, there was Thirsty Thursday was always a thing, but thirsty didn't mean anything at that point. So it was just a fun alliteration. Hey, May. I almost said Mayor. Is it Meyer? Hey, Clem. How you doing? Good to see you. Now I have to remember how to say your name. Oh, no. All right, let me close a couple of windows and then we're going to get started. So we're going to be working on, I should have kept it up, MC-10. Images, where is it at? Where'd it go? This one. Okay, we'll just pull this one up. So we're going to be working on a schematic for a computer we actually repaired on stream years ago. The MC-10, the TRS-80 MC-10, which I mistakenly back then called the Coco 1 because I didn't know the difference between the MC-10 and the color computer. But yeah, so we'll draw the schematic for this guy. And I'm not super excited about this one because the schematics are in terrible shape. So this is one of them. Let's take a look at this. Yep, that's pretty much unreadable. I did find on circuitguide.se, so I guess Sweden, is SE Sweden? There is this one, which is a little more readable, so we might try to use this one. And then I also found, same site, I found the service manual, and I just wanted to see, wait, I just opened that one again, didn't I? I meant to open the service manual. I wanted to see if this one, if the service manual had a better version of the schematic. My guess is that's where the other one came from. That looks like a block diagram. Oh, there's a nice view of the Gerbers. Man, you don't see that very often, even in this old stuff. So the service manual doesn't have the schematic. Okay, well, that kind of solves that one. Yeah. English pronounced, yeah, okay. You know, and actually, and I'm not trying to flex, but having spent as much time as I have in Germany and working with German colleagues, I always like, even when I think I know how to pronounce a word or a name, I always pause because it's like, well, is that the English pronunciation or yeah. Anyway, so yeah, so let's just get into this. What I wanted to look at is, let's just take a quick look and see what are some of the chips, like the MC-6803. That sounds very microcontroller-ish. 373. I see the video controller. What was it using for I/O? A 4016. I feel like I should know that. Yeah, I feel like I should know that, but that doesn't mean anything to me. Yeah, actually, I still am trying to just imagine Clem saying his name like when we used to do live streams together, and I totally can't hear it because all I hear is the way I want to hear it, like the way I would say it, and I don't know if that's the right way. So, okay. Well, let's just get into it. I think we'll start with the processor, and then we'll go from there. And yeah, we'll just kind of take it that way. So let's get this over here. Also, just a FYI, I am using KiCad 8 release candidate number 2. It is the latest release candidate. Since FOSDEM is this weekend, I suspect there's a high likelihood 8.0 could get released. And if it's not released tomorrow, then it probably won't be until after FOSDEM. However, I am hoping that they do a presentation on all of the changes because I started going through the 800. I think it's 800. It's either 600 or 800. Both are a ridiculous number. But I went through the closed issues with milestone 8. I think it's close to 8. Or that's why I'm thinking 800. I think it's like 622. And there's a lot. And so, yeah. Oh, man, I closed KiCad. Let's open this up. Open this up. First thing we should go ahead and do is create a library because we're going to need one. So let's do that before I forget. And then let's do, we'll just go symbol editor. Breaking out the nightly. Well, yeah, actually this isn't the nightly, which, okay, last week we found multiple bugs, but I could only repeat one of them. I tried so hard to cause the crash when we were editing text to happen, and I couldn't get it to happen again. However, in doing that, I found a new bug, and I submitted an issue for it, and then I thought of a feature, which was being able to edit the visible property of text labels in the new property editor, and I submitted that one Thursday night. When I woke up in the morning, they both had commits to do both of them. So I thought that was pretty cool. I was like, wow, that's good turnaround. I mean, granted, especially the bug I found was just it was something wrong with deleted components weren't actually getting deleted. So I imagine it wasn't that difficult to figure out. And then the request that I had was that seemed pretty simple. Anyway, let's do a new library. Keep it to this project, and we'll put it here. We'll just do TRS-80 MC-10 symbols. Yeah, symbols. All right. We're not going to create. Well, yeah, I guess we'll go ahead and create one right now. Let's do a new symbol and the symbol name. Okay, wait. We got to get organized here. I need this to be over here. And then I want this window to be slightly more bigger. And then I want to bring this over here. And I want to adjust this so that my head doesn't block this part. Where'd it go? This one. All right. So then we're going to come over here and we're going to do file, new symbol. Yeah, I've actually seen some of the work you've been doing, Clem, with FreeCAD, and it makes me want to give it another look. It's been a couple of years since I seriously tried to use it, but seeing the things that you've been able to pull off with it makes me think it's a lot more capable than it once was. All right, so now the way I like to do pins is the following. I'm just going to go into the pin table, and I'm going to say new, and I'm going to say 3, and the name is XTEL2. For the moment, well, I'm going to make it passive because I'm not sure, but you generally on, because I'm not sure if one of these is input and output, although I'm guessing XTEL2 is probably an input. I'm going to make this an input. Okay. And then let's see, 2 will be XTEL1. I'm going to leave that as passive. This is, well, I was going to say it's probably an output, but I guess not. Let's do IRQ. I wonder if that's IRQ1. Let's do a quick MC-6803 data sheet. I can't imagine. Why would it have more? Well, it could have more than one IRQ, I suppose. It was technically that good, but the UX wasn't. Yeah. Yeah, okay. Sure. Sure, why not? Oh, I see what they're saying. I think they're trying to say, okay, I think I understand now. I think this is trying to say, oh no, because NMI isn't, I thought, is NMI inverted? NMI is inverted. Oh yeah, it is, IRQ1. Okay. All right, whatever. IRQ, okay, but it's going to be, oh, the pin number is 5. The name will be IRQ1, and it's probably an input. And then 4 will be NMI. All right. So 8 is a P20, and I'm going to guess that this is, it's probably an I/O port, which I will assume until I can figure out otherwise. Yep, it's I/O ports. I'm going to assume it is tri-statable. I wonder. Oh, I'll bet if Squire was around, he would know the answer without having to look it up. I tell you what, we're going to make it tri-state just because that seems likely to me, and then we can always change it later. So now let's do 9 and P21. I want to try something. This might be faster. What if I did this? What if I said do a pin, and we say pin name is P22 and the 11, and it's tri-state. Okay. And then what if I hit the insert key? Yeah, but that didn't work. Nope. Okay, so it's P22, but it's pin 10. And this is P23, and that's pin 11. And this is going to be, so insert is the repeat last command, which is usually really helpful if you're doing something that has like sequential operations. However, it didn't work well this time. All right, so then we're going to do E, which is E an enable, I wonder? Yes, no, maybe so. See if we can tell by the block diagram. Okay, block diagram. E, okay, I don't know what E is, but it's clearly an output. Okay. All All right. Very well then. We will keep it. We will make it an output. It is not an input, despite what I thought it was going to be. Womp womp. Output 40. I was thinking it was like an enable pin, which I don't know. Why would a microcontroller have an enable pin? I don't know. But or microprocessor. This is not a microcontroller. Okay, so this one will do P10, 13, tri-state, and I think we're going to get away with being able to do a bunch of insert to save a little bit of time, because it goes 11 and 14, 12 and 15, 13 and 16, 17. Remember, I'm just pressing the insert key, and it's just repeating the last thing, and basically repeat and increment. 15 and 18, 16 and 19, 17 and 20. Okay, that looks good. Now the downside is, let me see if they change this. If we do shift insert, yeah, it's still there's not. Oh my goodness, what did you do? Come back, come back, come back, come back. Oh, that's interesting. If you undo, it undoes the entire repeat session. I was not expecting that. I was not expecting that. Hey, Francois. Good to see you. Are you ready for your session at FOSDEM this weekend? I don't know why I asked in a very fatherly tone. That was not that was not my intention. Okay, so now let's do pin 1 VSS, and that's going to be a power input. Remember, ground is still considered a power input. You know what? Let's go ahead and do. I forgot to do these at the top. Yeah, it still wants just down to the bottom. So let's do 7 as VCC, and then 21 is standby, which I assume. Let's see, VCC crystal. Okay, so those are both inputs. I can change that back. No, it needs to be passive so that I can tie it to ground. Otherwise, KiCad will get upset. Right? No, that's only on outputs. Never mind. I don't know what standby is. VCC standby. Oh, I see. It's a power input for the RAM. Oh, I get it. Okay. And then reset is obviously an input, right? I say obviously, and then I'm going to like see something that makes me realize I'm wrong. Okay. Tell you what, let's save this so far. Okay. Now we can continue. Okie dokie. So let's do a left. And then we will do bi-directional. I wonder though, because if that is data and it's the lower half of the address bus, I wonder if it is tri-statable or if it's bi-directional only. I still don't even know if the I/O ports can go tri-state. Well, I'm not going to waste time looking it up now. I'm just going to say bidirectional, and then we can get corrected later. Okay, so let's do D0 or D0. Okay, I got an idea. Even though this isn't going to work out ideally, which is going to be faster. I kind of want to do this. I want to say make me a pin 22 for this side, and then give me 23, 24, 25, 26, 27, 28, and 29. And then we'll have 30, 31, 32, 33, 34, 35, 36, 37, 38, and 39. All right. So then I'm going to move these over here, and I want up to 30 over here. And 37. Did I just duplicate 37? I did. Okay. So I did that to at least save us a little bit of typing. Now, let's go back to the pin table. And so here, one thing I'm going to do is I'm going to copy and then, nope, I guess not. I was thinking I could copy and paste. Okay, you know what I am going to do though? Ha 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 ha. Nice try. Nice try, KiCad, for I have a trick up my sleeve. As soon as I make sure I don't have any passwords showing. Okay. I'm going to take these pins, Control X, paste them into Mr. Text Editor, and then we're going to do a Control G, Control H, and we're going to find tri-state and replace with output. Replace all. And then I'm going to copy these and paste them back. And ta-da! It's a magic trick. That's my favorite trick, actually. Okay. So now we can more easily just come through and go, oh, come on, get small. Be more small. Okay, I guess I don't need that. So then we can say, okay, pin 22 is A15, then A14 and A13 and A12, 11, 10, 9, and 8. So then pin 30, so these, okay, I'm going to say okay on this for the moment because these should have all been bidirectional. So what I'm going to do is I'm actually going to cut this. We'll go back to Mr. Text Editor and I will change. What I want to do is I want to change, no, what is it? H. Now I want to change tri-state to bidirectional, replace all, cut that, paste that back in. Oh, so pretty.
There was much rejoicing.
Yay. Yay. Okay, so if I come back into the table, dust, A15, A7, actually, it looked like a feather. I wonder if I had a pillow or something. So then we're going to do I'm going to do AD7. I'm just going to call it 87 and 86 and 85, 84, 83, 82, and 81, 80 for address data because that's a little bit easier. And then 38 is a read write, which is highly likely an output. And then pin 39 is the AS pin. Wait, what? What in the world is it AS? If it was AF, that would be epically cool. I would be like, I want to use this processor now. So I don't see an AS pin anywhere. There it is. AS. Well, whatever it is, it's bidirectional. Expand it, multiplexed. Expand it, non-multiplex, single chip. I feel like I should know what that means. Okay. I mean, I know what multiplexed and non-multiplexed mean. Like, I wonder, are those different chip designs or are they different operational modes? All right. Okay. So there we go. We've got all of the pins for the most part. Uh-oh. So where is pin 7? Let's move this over here. And this one over here. And this one over here. Okay. Because we're going to move these. Oops. We're going to move these up here. Move this down here. We'll probably end up modifying this symbol so that it fits the schematic better. But we can at least get a little... Uh-oh. Wait a minute. Those aren't facing the right direction. No, they're supposed to be left. Why aren't they left? Oh, for F's sake. FFS. So I think we change this to change its orientation. So let's do this. I should have just left these in here because we need to change them all. Oh wait. I forgot. This is KiCad 8. Can we just highlight them all and go left? Oh.
There was much rejoicing. Yay.
Yay. Okay. That's pretty awesome right there. Yeah. I forgot. We have the properties panel now. All right. So this orientation should be down, I think. Yep. Nope. Yeah. No. This one goes up. And then these go down. Switching now. Yeah. I didn't think the property panel was going to be such a big deal, but, well, here we are. Wait, what is this? Okay, I can write on this. Okay. And then let's move this over here. And then let's just kind of clean these up a little. I don't want to spend a lot of time organizing this because, like I said, we'll probably end up modifying this once we start drawing the schematic. But if we can get pretty close to a good symbol, that would be nice. Because this looks like it's really well written on a grid. Like E should be here. And then A0. Oh, by the way, the PCB we drew. Wait a minute. Didn't we draw the PCB last week? Okay, well, it's in the mail now. I just realized it. Oshpark Swifted it, so it basically went into production on right after we submitted it. So it's the PCB. It's an extender for the Mega 2E, so I can actually plug expansion cards in. It will be here next week, so that is exciting for me. I need to turn my other cursor on. Where is the big cursor? Yeah, wait a minute. The toolbar on the left isn't here now. So how do I change my cursor? Huh. That's weird. Symbol editor, display options, grid style. Okay. Oh my God. It was right in front of my face the whole time. Are those lyrics to the Cops theme song? Oh, no, I want that to come back. What am I doing? I want that to stay. Yeah, we don't want the properties manager to go away. No, sir. No, sirree. You come right back. All right, so we got the standby, reset. Okay, let's draw us a polygon. That looks terrible. Let's move all this over by 1. Expand this by just a smidgen. Let's do its fill color. Body background color? No, that's not right. Oh, it's because it's highlighted. All right. So now let's bring this into here. So where is the value MC 6803? For now, I'm going to grab this one until I find a better sheet, a better data sheet. Microprocessor. Oh, Pet Shop Boys? Okay. Like West End Girls. Is that the... I'm trying to remember. That was actually... So growing up, my brother, when he graduated high school, he got a CD player. I didn't even know CDs were a thing until he got it. Because this was in the 1980s. And one of the first CDs he got was the Pet Shop Boys. And I remember West End Girls being... I feel like I should know the album name, but West End Girls was on it. Okay, so where's the middle of this part? So this should have been right there, and this should have been right there. So my alignment trick in Schematic and the footprint or the symbol editor is the polygon has the midpoints on each face or edge, and so I would prefer alignment tools, but I'm just gonna look. I was just thinking I better make sure that they don't exist yet. Because like what I could do is if we look at this and said, okay, so right there, I'm just going to do this so I can see that. And then that's going to be an obvious one. Okay, so now I want to move this whole thing. Where's my grid? Did I turn the grid off? Because like, where's 0, 0? What happened? So I haven't gone back to verify this tangent, but there was a lot of discussion in one of the KiCad issues, on the KiCad 8 issues, on whether on unmapping the hotkey for change grid in Schematic. And I think the resolution they came to was at least make the defaults valid grids, so that even if you accidentally switch between these, at least it's relatively easy to fix the grid issue. But that said, I don't know why is my grid broken. Like I don't see 0, 0 anymore. I think this might be it. I'm just going to make a guess. And I guessed really darn good. Okay, it's right there, but I can't see it. So what I was going to do is I was going to go and just turn lines on just so I can see. That doesn't really help that much. Maybe it does. There. So that should be the center of our part, and we should be at 0, 0 now. Okay. That's weird. I'm going to try something. If I leave the schematic editor, or the symbol editor, and we come back, okay, and then I'm going to do MC-803. Wait, what? Oh, what is this? Are you kidding me? Well, that's not the right pinout. Okay. Okay. So right now, see, it came back. But I wonder if when I changed the cursor, if that's when it disappeared or something else we did. Huh. Yeah, because we definitely caused the origin to disappear, but I have no idea what did it. I might actually just go back in time and see if I can find it. Okay. Okie dokie. Regardless, we have our initial symbol, so now we can go and get started and get some real work done. We could spend time and create all the symbols and then start drawing, but that's boring. I don't want to do it that way. Oh, this is still slow. Come on. That shouldn't take long. All right, so this is going to go down here somewhere. Oh, I should take that line out. We can take the line out later. Not going to worry about it. Let's get rid of the hierarchy, and then I want it to, while we're here, oh, I already know this page is not going to be big enough. All right. So we'll put that there. No, really, Windows, really? Yeah, because then there's no way for me to, there we go. Okay. So, oh, I didn't quite line these up, did I? Oh, we're not done with this. Let's do edit. Well, I'll do edit here. I'll click on this, edit library symbol. So these need to move up to line up with this one, which causes that to happen, but I just don't know what else to do there. This should be an input. Oh, I do like this property editor. It is really nice. And then A10 should be up here. Sometimes it's the little things. Okay, so we'll close that, and then we'll do an update symbol. I don't like how 17's on the bottom there. You need to finish packing. Nah, you should always pack. You should always pack first thing in the morning. Nah, I used to always pack the night before. Always. Even if I had like a nighttime flight, I would pack the night before because I had reasons. Okay. So let's see. Let's do this reset circuit first because that has some stuff in it. So we're going to need a 74 LS14. And let's go number 1 there and number 2 there. So these are part of the same units. And I wonder, are those U1 or UI? Are they UI or U12? I see a 15, but that could still be UI5. I see, let's see, what is this? This is not numbered. So I don't think they're doing the Apple thing where it's like in a grid by any means. This is not anywhere near that nice. See, that's U16 maybe. But I'm starting to think, well, what are these? These are 18, 19. If I see a 20, then I'm convinced. 13, 12. That would be, okay, well, it's not going to be UI0. So yeah, so it's a, what's going on? Why can't you do that? Okay, so it's 12. All right, so let's fix these numbers. So this should be U, oh God, so nice. So nice. All right. And then this connects to this. And that is going to connect to this. So using W to draw the wire. And that's connected to there. And then let's do a R small. All right, and let's do a C. Wait, what's the polarized cap? Is it polarized? Small. And that's going to go, looks like about there. And then let's do a diode small. Diode small filled. That's going to go roughly here. And then we need a single pole, single throw. What's it? I thought that's... Yeah, nope. Should be a button. Push button. There we go. SW push. And that's going to go about there. Okay. So this is where I was like, there should be a visible thing here. And I think there's going to be, which is awesome. So then this will be, let me click on here. And we're going to make this reference be C8. And its value is 4.750. Well, I'm going to put 4.7U because I'm fairly certain that's a 4.7 microfarad since it's an electrolytic and 50 volts. All right, for this resistor, that would be R24 and it's a 100 ohms. And then this diode, I'm going to hit Y. Nope, I'm going to hit Y twice because it's not what I wanted. So we'll use X to move the labels to this side. And then we're going to make it be diode 9. And it is a 1 in 4148. I have no idea what my brain just tried to do. And then this is going to be just S1. And we will move its label over here as well. How pretty is that? Okay, so these two connect. These two connect. This connects to both, and then we'll put a junction there. Oop. Then we'll do a wire to here, a wire to there, and then we'll add a plus 5 volt. Ooh, I know what I want to know. How do we create? Okay, I'm just going to make a note. I don't want to waste time doing it right now, but I forgot. I think we're supposed to be able to create custom power symbols now, or more easily. So we'll need to figure that. I want to figure that out. I don't want to spend time doing it at the moment, though. I'm trying to build up. Here's my kooky video idea for when 8.0 is officially released, or right after it's released, I want to do a video of my top 8 new features for KiCad 8. Get it? Because 8 and 8. I know it's sometimes I'm just beyond clever. But anyway, that's what I want to do. All right, let's bring this to there. I was trying to do something fancy there. Changed my mind. All right, ground symbol. And see, like, this is another one where I would really like to be able to just go not visible. I don't want that text to be visible. And I'm going to assume that since this is in a plastic case with a DC input, that the rake symbol is not actually mean earth ground. Okay. Whoa. I want to save this one. All I want to do is have some KiCad fun. Ha 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 ha. Okay. We're going to do 5 volts to here. And then this one's going to come to here. We're going to come over here. I will connect these. We'll junction this. And then we need a C small. And this is going to be a, what do you call this? This is a C27. And it is 100 nanofarads. How do I know? Because I do. I just do, all right? Yeah, I mean, they're just doing a small ceramic for decoupling there. That's pretty clear. I don't know why. My preference is to say, put ceramics in nanofarads. And, well, unless it's like a big MLCC. And put other, I just think it's more descriptive. Okay, so then we've got a couple of pull-ups for IRQ and NMI. And let's grab this and this. And so we'll do an X on that one. And then I'm going to be a little, oh, you know what? Change my mind on this because they're both the same value. So we're going to do 4 7K. And this is R23. And because this area is starting to get a little bit tight, I can't change the size of the text there. That's frustrating. I want to move this inside of the resistor. We're going to do that. And then I want to copy and paste this and hit X to do something like that. And 22. Okay. And then those are all going to connect to this 5 volt rail, which is so exciting. How exciting. All right, let's move that over 1. All right, and then external, this is going to come up here at some point. We'll worry about all that in a minute. And then this is going to go to ground. How do we want to draw that? Because if I just take the ground symbol and do something over here, that is in the way. So I think what we're actually, this is a good example. I'm going to go and edit this. I'm going to move these 2 signals, or these 2 pins down a little bit, because I want to have room to be able to have the ground symbol attached to that pin. I'm also, this is driving me crazy. I don't care if I'm going to change the name. We're just going to call this EXTL2. That looks much better. And then these, we're just going to move down 1 grid space and see what happens. So let's do update symbol. So anytime you change the library symbol, you have to do update symbol, because you're basically saying, well, the copy in the schematic is its own version from the library. So you have to update it from the library, even though we told KiCad to go to the library and edit it. It's kind of, it probably doesn't make sense like the first time you encounter it, the behavior, but it does make sense because I just said so. Duh. All right, we'll do that. And then this one also wants a ground, I guess. I'll just do that. All right, So then what I can already tell is we need to move this stuff to all be a little bit tighter. So I'm using the G hotkey to basically move these symbols. And I always try to have one grid of wire. There used to be, and this was like very long time ago, there was a bug in the way that the wires got connected, and I've never forgiven KiCad for that. And so because of that, I always try, not always, but I really try to when I basically bring this up to here, I always try to have the grid, that extra grid space. All right, move that to here, and then we'll just connect those two there. Because I'm trying to make sure I have room to bring this thing. Yep, see, we still don't have enough room. All right, visible. Although I probably, depending on how far that's going, we may just make that a label, because that's ridiculous. Yeah, that's pretty ridiculous. But for the moment, we'll go with it. Okay. So, man, where is that going? It's this line right here. Connects to here, connects to there, and then goes into there. And then it connects to there. And it connects to there. Okay, if you say so. Worry about that later. That's a good problem for future us. All right, let's keep going. And let's see. So P20 is we'll just do, okay, so here I'm going to do a couple of these lines. I'm going to hit insert, and just this way we just have a whole bunch. Fail. Okay, I'm going to edit this symbol. We're going to move those up anyway because I don't like this. Update symbol. All right, so if I redraw this, are we back on the grid? We are. Good. Okay. Yeah. Okay, so now we're going to do L for label. And let's see. I don't know what RS/C out is. Is that, I wonder if that's supposed to be RS232. Is that RS232C out? Is that what they're trying to call that node? Like, did you really have to add the C to this? CD. Is that carrier detect? I don't know. That can't be. Because then what's CN? I wonder what that is. And I just realized I'm doing this wrong. So P20 is P20 and 22. Okay, I messed this up. So P20 is RSC out. 21 is something else. CN is 12. All right, so I see what they did. So then they said, okay, well, we're going to bring this down over here and do all of that. Okay, we may end up moving some stuff. Let me think how we want to do this. So this instead, I should have done something like this. And then we can label this as shift. And then these, I don't know what KR is, so KR is 0, and I'm going to place that, and then we'll get the rest by hitting the insert key. And somehow, I did it again. I got off. because there's the E. So I'm going to highlight the labels, hit M, move them down, and then I realize I forgot 7. All right, got it. So E, whatever it does, we're just going to do we're going to basically do the same thing. And then for the moment, I'm just going to do this because I'm not sure what to do with it yet. All right. So, see what I'm really inclined to do is just say, okay, this is RQ1 and this is NMI, right? All right. Okay, so let's copy this diode, and then we're going to put a diode here and a diode maybe here, and then those are going to go somewhere else. Okay. And that's because RSC is going to go to, whoa, what are you doing? X. Whoa, what am I doing wrong? Oh, W. It's W. What the heck am I doing? All right, so that connects. Nope. This connects to this one. This connects to this one. And then we're going to do a little bit of cleanup. So this is supposed to be D8. Hey, Sam. Overheating Shelly? Huh. No idea. Yeah. If you have like any kind of thermal camera, you could look at it and see if if it's obvious. I guess it'd just be the SoC, so that's probably not very helpful. All I can think is there's something damaged. All right, try that. I mean, I think those are ESP32 based, if I remember when I looked at them the other day. I don't know if Expressive did anything to improve the ESP32, but I know the ESP8266 was incredibly ESD sensitive. Like I lost a lot of those chips and those modules to ESD. It was really frustrating too, because like the chip would be working fine and then it wouldn't, and then all of a sudden it wouldn't be. Wait a minute. So this, they're saying this is reset? Oh, I see. So this actually connects to the reset signal. All right. Sure, if you say so. I am tempted to implement the color code that this guy is using, because it is kind of helpful. /C is for cassette. Oh, interesting. All right. So they're saying it's probably RS-232, cassette out, cassette in. Then what's CD and CN? Oh, unless is this supposed to be C out. I wonder if this is an O instead of a D. So you think it's carrier detect, huh? Let's take a look up here. No, that's definitely a D. That's very flat. That's very O. Okay, so this is serial IO. Okay, I think you're right. I think it's CD. Okay. All right. Oh, E is to enable RAM or ROM. Ah, yeah, okay. And AS is address strobe. Okay. Totally make. Yep, you're right. That makes sense. All right. So let's see now. So E, oh, it does go somewhere else. Darn. I was hoping it didn't go anywhere else. Because I think to make this cleaner, I would rather just do this. We're just going to call this, oh, stop zooming around, man. E. And then what was the other one we were talking about? Oh, AS, the address strobe. Well, we'll worry about that one in a minute. Okay. Status input line. Oh, what'd you go and look it up for? That's no fun. That kind of ruined. No, I'm just kidding. Just kidding. Okay. So those are more or less done for now. Let's move over to the address side of this thing. And ignore it completely because that looks really painful. All right. Let's see. Let's do, oh, you know what we should at least do is let's at least add ground. Tell you what, let's ground and then move this stuff to be right here because that's sort of how they did it. And then before I forget, let's get rid of that line. So I'm trying to get the line, but it's selecting the shape. So I'm going to left click and hold, which brings up the clarification context. So I can select polygon with 2 points, which is the polyline. Or you can also press 1, 2, or A for all. So actually I'll hit number 2, selects the line, now I can delete it. Everybody wins. And then we got to do the update symbol. Okay, let's save that. I do want to do one more label up here. And I'll drag these over a bit. Bring this to here because EXTL2, I don't think I'm going to end up drawing a line all the way across the sheet. All right. But now effectively we've labeled the left side of that. So that's good. Charles de Gaulle. Okay, so over here, we're going to do... So they called these data lines, even though they're not connected to anything else. Oh, I see what they did. They made this a data bus. Okay. Okay. Yep. Yeah, so that's what they did. So yeah, I think we're actually going to go with that. And then let's do a label. Let's go D7. And then, oh, you know what we got to do? I got to do a label. I'm going to do D0. And then I'm going to get us up to 7. I'm going to highlight all of them, hit Y to turn them upside down so we get 7 to 0. And then I'm going to X those. I'm going to move this over by 1. I'm going to wire there and then insert those lines. Whoops, one too many. My bad. All right. Why isn't... Oh, I'm using these wrong. All right. These need to go here so that these can go here. And I don't like that. There. That's better. That should be cleaner. U2, yeah, U2 does yeah, and then this makes sense because now you got your strobe connecting to here. Although I'm surprised this strobe doesn't go anywhere else. But okay. But I guess the idea is after this guy creates the address bus, it doesn't really matter, does it? Then the rest of the design probably just has 2 separate buses. Okay, so let's see if we can just use the built-in 737 or if we're going to have to make one. I'm hoping we can just use the... Nope, we can't use it. Where's pin 14? Pin 13, pin 8. I don't care if, well, okay. So what we're going to do, so we're going to create a specific version. So what they did, I mean, on these latches, even though they're labeled D0 through 7, the latch doesn't really care what the bits are, right? It doesn't know what D7 is. And so what they're labeled as is kind of pointless. But I do want the pins to match the schematic, which also means like 14 and 15 should be in line with each other. And so if we're going to move the pins around, we might as well change the labels as well. So what we'll do is we'll do edit symbol, but this time I'm going to do symbol from the schematic just because, well, we could do that from the library. I just want to make sure I don't overwrite the library because now I'm going to save. Oh, wait, maybe I did want to do it that way. My bad. Yeah, because I want to do save copy as. I guess we could have done it the other way. So we're going to say 743 LS43. I'm going to add an MC just because it's going to be special to this schematic. Actually, I'll make an MC-10. All right. So we'll save that. No. So now I should be able to look for, let me close this. This is a little, I thought this was going to come out a lot smoother than it did. So if we search for our MC-10 library, it's not in here. Okay, 74 LS 373. I'm going to load that. We're going to do a file, save copy as, name MC-10 in the MC-10 library. Okay. And then I'm going to double click on this one. I'm going to hit save. So now we are editing This should be the one we're editing. Let's just see. Okay. That looks more or less correct. Man, I wish there was a way to turn these off for the moment. Okay. Okay. All of that so that we could come in here and start fiddling with this. I think the way I want to try this, let's see, what's going to be the best way to do this? If I come to 3 and I type 1D, no, we're just going to do, I know what we can do. We'll make use of the property window. So if I click on this, then we can go, I want this to be 14 and I want it to be 1D. And I want this one to be 13 and 2D. And then is that 8? Yeah, I'm going to guess that's 8. You know what? Just because 3, I feel like even though I'm going to click on it twice, it's just faster if I come in here and do it this way. D and 8D. Okay, so then we want 8 and then the pin 4 and pin 3 and pin 18. So I always bring this up just because if you're newer around here, you might be saying, well, why don't you just like do OCR or something or machine vision and blah, blah, blah. Well, here's a good example, right? Look at 18 and 6D. I don't know how to write code to figure out what those are supposed to be. And the way I'm figuring it out is I know that this is obviously going 1, 2, 3, 4, 5, 6, 7, 8. And I know that 18 and 19 should match each other because of the way that this chip is laid out. So, although that actually surprises me now I think about it because they're doing input and output next to each other. That's weird. Anyway, like I don't know how you write code to do that. I feel like by the time you write the code to machine read these terrible schematics, you could just draw them faster. So, okay, 14, 13, 8, 4, 3, 18, 17, 7, and then 11. Plus by drawing them, we are learning a lot about how these things are, like we learn a lot more about them. All right, I'm not going to do the exact layout that they did here because I don't like the output enable being on the right side because it is an input. Even though I guess they're doing it over there because it is the output enable, but whatever. It's my stream. I can do what I want. Okay, D. Oh, how am I going to do this? I don't want to move my hand back and forth. This is, I need a better way to do this. Four, 5, 6, 7, 8. Okay. And now we can go and fix the pins. So this should be 15. Then 12, then 9, then 5, and 2, and 19, and 16, and 6. Go to a better way to do this is to build a time machine, go to the next morning, steal a copy, and then come back. You're done. It's like, gosh, that's so easy. Why don't I just do it that way? God, that would be way easier if I just, use the time machine and go and get the done version. All right. So we have 14, 15, 13, 12, 8, 9, 4, 5. I love that. 18, 19. I might steal that and use it in a video. Okay. Save this. So now, fair use. Yeah. Is it stealing? I don't know if it's stealing. I don't know. Ever since I watched the H-Bomber guy video on plagiarism, like I'm super paranoid to accidentally steal anything from anyone. I just, because like, for example, so first it's a 4-hour video where he basically demonstrated how there was somebody that was a very prolific plagiarist, to the point that the person has completely deleted themselves from the internet because it's impossible to defend. But what kind of made me think is, like, when I write Hackster articles, a lot of times I go look at, like, if I'm writing about, I'm just going to pick automotive Ethernet. If there's a standard or something like that, I'll put the name of it into the article, but then it's like I always like to add 1 or 2 sentences to put some context around, the technical name. And so what I normally do is I go look on Wikipedia and see what Wikipedia says, and then try to paraphrase, like, usually the opening paragraph. But 2 things. One is I always try to paraphrase it, or I try not to just literally copy and paste. And then the other thing is, if I do that, I almost always link that word back to the Wikipedia article, because to me, I just saved myself. If I was reading the article, I just saved myself the time to do what I just did. Because it might be, well, I don't recognize this term, so what does it mean? Now, in contrast, and what gave me pause in this video, this expose, this guy was reading entire Wikipedia articles as if he wrote them himself. And it's like, wow, that takes some balls. I mean, you just straight up, like, yeah. And then of course, yeah. Anyway, I totally don't know how I got onto that rant. Wasn't paying attention. Oh, because I didn't want to steal a joke. That's right. Thinking fourth dimensionally. Yeah. Back to the Future 3. So even though I like to do this just because we're going to have that bus there, I like to do this because I think this makes this a little more explicit. Or should I do this? Maybe this makes more sense. Yeah. I don't know. There is, I have noticed, and I don't want to sound like an old man on this, but I have noticed how the generation behind me doesn't actually seem to understand intellectual property theft very well. Like, it seems like their attitude, most people that age, their attitude is, well, if it's on the internet, it must be available for free. And that worries me, because that's not how stuff works. And I don't mean like in terms of like cost, that it should be free, although I think a lot of people think that. But I mean information, especially. Just because it's available on the internet does not mean somebody did not put time, effort, and energy into it. So, yeah. Okay, Francois. I think you and I are actually kind of on the same page. That's sort of where I was going with that. So did the guy on the video cite his source? No, absolutely not. That was actually what was so blatant about it is, so just I'm not going to say his name or anything because I just feel like you can go watch the video if you're really that interested. But just to give you an example, he had been making videos for about 5 years, I want to say, like on the order of 5 years. And he had been caught multiple times plagiarizing, and he always had an excuse for why it wasn't plagiarism. And then this particular video from H Bomber guy, it's 4 hours long, and he goes into detail on the times he found plagiarism, and it was like it was just blatantly obvious, right? And for example, when he was reading an entire Wikipedia article, he doesn't cite Wikipedia anywhere. Now, where I was going is he had been caught like a couple years before this, and then he started saying, well, this is based on the works of, yet he still wasn't citing everybody. Another one was, anyway, I'll just stop there. As somebody who creates content for a living, I think it was something that resonated with me because I'm always paranoid about plagiarizing. Like, I don't want to, like, I'm always worried that I'm not giving enough credit to either I'm not giving enough credit or I'm overusing another source for the things that I'm doing. Regardless of what I do, I always think that. Like, it's always in the back of my mind. It's something I'm always worried about. And to watch somebody who built a career where he was making, there were estimates on the order of $15,000 to $20,000 a month on Patreon from his viewers, and he literally was just reading Wikipedia articles in his videos. Like, geez, all this time I made the mistake of writing everything myself. Like, what was I thinking? Why didn't I just do that? It just cracks me up. Like, how do you do that and think, yeah. And I don't want to go there. The thing that really bothers me about it is there was another YouTube personality. All I'll say is he does finance, and somebody noticed that he seemed to have some repeated or some stuff out of articles. And I spent 2 hours, and in 5 videos in a row, I found at least one article in all 5 that he didn't cite. And it was like, it was so disappointing because I really enjoyed his content until I realized he also just plagiarizes the majority of his content. And it's like, and for that person, I'm not going to say who that is, and I'm not doing anything about it because I don't think he would just disappear. I think he would take legal action, despite the fact that he's clearly the one doing something wrong. Anyway, I shouldn't have said that. Use AI to post stories from Reddit to TikTok and YouTube. Yep. Or just AI to generate content. I mean, that's another, I think most of us are probably familiar with sort of what's happening with AI stuff is I think people are using AI. So one example is I think people are using AI to generate content from other sources. And in their mind, they're thinking, oh, well, I created this, so it's okay to do it. And it's like, well, no, you didn't. I mean, first, it's AI generated. And second, it's generated from other people's content. It's not your content. I mean, this is sort of... this is a little bit of a, well, for example, there's like if I, most of the channels I follow on Instagram are they're like dog related because I like puppies. And one of them was like the puppies of Instagram or something. And it's basically just an AI generated channel resharing content on Instagram. And, I think and maybe that's not the one I'm thinking of, but there's one that I came across where they don't even tell you what channel they got the video or the photo from. And it's like, really? You're not going to at least be like, hey, if you like this, like in the case of dogs, it's like, if you like this particular dog, wouldn't you want to share who the actual creator is? Why wouldn't you? Yet, people don't. So, all right. Thanks for coming to my TED Talk. It's not actually mine. I borrowed it from somebody. Just kidding. I don't know how to do this. This is gross. I need this to come over here, but everything's in the way. I guess we can move this down, but then I don't want that. I guess what I could do, I don't think I like this better, but I don't like any of these other options. So what is the option I hate the least? Yeah, I'm not a fan of that, but I don't see how else to do that. I'm not sure who Kyle Hill is. I'd have to look at him. No AI, just... Yeah, I think the other thing is, I think the... So, yeah, it's actually, come to think of it, it's in a lot of these cases, it's not even AI, it's just a script. I think myself included, everybody seems to assign the word AI to a bunch of stuff that actually isn't AI. It's like just straight up a Python script. But all right, let's do a quick label and do A150. All right, and then just so we have it labeled over here, let's do D to 7. Flip the cap 90 degrees. I guess since we're in the doing things I don't like mode anyway. This does look, of the options so far, this is the one that I hate the least. So, okay, that works. Because then we can even move this down like one click, one grid. Yeah, and that looks a lot cleaner. Then I can move this back over just to give that a little breathing room. Yeah, okay. Yeah. Yeah, okay. Yeah, thanks. That's actually, I don't know why. I don't like to do decoupling caps that way, but that definitely looks a lot better than what I had. That gives everything a little more room. It's like what I would like is I would like this to come down just once. Nah, we'll leave it like that. That'll work. Okay. Well, that's pretty fancy looking. Okay, so that's U2, that's U1, 74 LS373, address, cap, ground. Okay. Yeah, let's do U3 now. What the heck is this? What is a, oh, that's not what I wanted. What is a MB8364 bit savers? Okay. So BitSavers has tons of cool stuff, and one of my favorite thing about them, let's see if it's on here. People are downloading the entire site through the web interface, and at first you think it's going to say stop scraping, and instead it's like, no, just use rsync, dummy. I love it. It's like, no, stop doing it the wrong way. Okay. Yeah. So is this, wait, are these just RAMs? No. All right. So then what is a TMS? Oh, wait. Oh, is this the ROM? I bet this is the ROM. Yeah. So that's probably what it is. The MB834 8364 is probably the masked chip from Toshiba. Like they probably got it from Toshiba. And then the TMS is probably the EEPROM. Assuming that I assume they use a masked ROM. I can't imagine that they didn't. Oh, maybe not. Maybe I'm talking out of my butt. Because these part numbers don't match what I thought. All right. Regardless, doesn't really matter. So we might be able to use an existing symbol or at least modify one. So let's just look for a 2564 and see what comes up. Nope. Okay. Second idea. Let's just go to memory. EEPROM. Erasable. Programmable memory. And let's look at a 2764. 28 pin. That's not going to work. What's the C? That's not going to work. Oh, I see. Wait a minute. Oh. Wait a minute. There's two pinouts here. I don't like that. I see what they did now. I see what they did. Hold on a second. I want to look for something. Where did I put? I have a picture of my MC-10 motherboard. I just have to think where I put it. So I did something for element 14. And it was a contest, and people had to guess what the circuit board was. And I showed a picture of my MC-10 with all of the I took off all of the labels on all the chips. And I thought that it was obscure enough that people would not recognize it too easily. It turns out it took about 10 minutes for 3 or 4 people to identify it immediately. I was like, wait, what? Okay, it's under puzzles. Guess the PCB. Okay. So, yeah. So full board. Okay. Yeah, just to compare. So I went through and I photoshopped out all of the chip numbers. So like, here's the same board, and then here's the board with the chips. So what I wanted to look and see is if we could find how they did the board for this one, because this is kind of weird. So we're looking for U3. Oh wait, not that one. This one. U3. The other mistake I made was on... I left the model number somewhere. I forgot to take it off of something. Somewhere on here it said MC-10, and people noticed right away. I thought it was actually on my board here. But there's an obscure reference to the MC-10, and I was like, are you kidding me? All right, so that's the 6803. That looks like our latch. Maybe? No. Maybe. That's a 245. What are we looking for? We're looking for U3. Yeah, okay. This is what I wanted to see. So yeah, so they actually did lay this out on the board where you could use, and I'll bet this is either so that you can use a masked or an EEPROM. So you can recognize the ORIC board. I just, this is just not, I mean, this was not a super popular computer, right? And I just figured, like, for example, I don't know. You guys are going to be like, oh, I told you. So this was like the first, wait. Oh, yeah, I know what I did now. Now I remember. Okay. So I showed this, and I realized almost immediately, well, in retrospect, I shouldn't have had the part numbers on this image either, because I thought what I was going to do is show this and be like, oh, nobody will ever figure this out. And then, like, almost immediately, it's like, okay, well, if you know it's a 6803, you could probably start to narrow down what it is. And then I think on the second one, it says MC-10 somewhere. Yeah, no, one of these, maybe, because yeah, yeah, one of these, it said MC-10, and that's when I was like, are you idiot? I really thought I left it on here. I don't know why I'm wasting so much time on this. I don't know. I'm looking at it now, and I know what it is, and I don't recognize. So what the heck? Top. What did you say? At the top of the pick. Is this the catalog number up here? The 2026. Yeah. I wonder. I don't remember. Or top of the board or top of the pick. Yeah. I thought there was something that said MC, like the MC-10 connector or something. Something dumb. Anyway, it doesn't matter. Okay. So all I wanted to know was this right here, which is, it is actually pinned out for both. So here's what I think we'll do. Okay. Back on topic. Come on, James. Come on. Let's see. Is there a 24-pin memory in this? So it would actually be under ROM. Nope. I don't think we could use an EEPROM. Would a 2464... Why are these all serial? How do you know they're serial? Whatever. I guess that's all that's in there. Whatever. All right. Whatever. Oh, I just don't want to create... I can't believe there's not... Okay. I'm going to start with this device because the pins are already defined. So let's do this. Let's just create one. What I'm going to do is I'm going to create a 20, what do they call it? We're going to create an 8364 pinout, and then we'll just do the same thing they did, and we'll just put parentheses for the other ones because I think that's how I want to do that. Hey Shark, welcome to the stream. So the 20, 26, 10, 11, yeah, whatever. Whatever. The next contest we did was I did a slow okay, I'll just show. I think this will work if I already closed the window. Okay. So the next contest that we did was I took a slow motion video of a electrolytic capacitor exploding, and people had to guess at a minimum you had to get the voltage and the capacitance right, the rated voltage and capacitance right, and then I suggested people guess the tolerance and maybe temperature rating or something, like try to get as many of the other aspects right, because I knew at least one person would probably guess the right combination. And ironically, I don't think anyone got the exact combination right. There were a lot of guesses, and a couple I thought were an interesting. Were kind of interesting. The thing that nobody asked me though was like, I don't think, or maybe I provided the dimensions, but like I would have done it by dimensions and would have been like, all right, well, anyway. So let's go create a symbol. Sorry, I got so sidetracked it. So come over here and then let's do a symbol editor. And we're going to kind of the same thing we did before. I'm going to look for a 2764. So I'm going to load that, and then it's a derived symbol. Symbol graphics will not be, what in the world? Oh, it's from the 27C64. Well, that's interesting. Well, I'm going to do a file, save, copy as, and this is now going to be in MB8364. And we're going to put that into the MC-10 library. Right? Yep. So then I'm going to double click on this one, which should load this one, hit save one more time, and we're there. Okay. So now we're going to do an edit, and we'll take out the data sheet because that's the wrong data sheet. And we will change its package, even though I'm actually tempted to not even bother because it doesn't really matter. Description will just, I'm just going to say EEPROM. I don't actually know how big this is. This is one of these things I'm not good at. Is it actually 64 kilobit? I guess that's what the 64, but, or is this, whatever. We're just going to say EEPROM. Prom. We'll call it a prom. Okay. So that, I did that so that we can then go into this pin. We're going to make this 24. We're going to make this one 12. And then our data pins, which on this symbol, okay, so we got to change these anyway. All right, whatever. You know what? No, we don't. I'm not going to change them because it doesn't matter. They're just getting driven onto the data bus anyway, right? Yep. So that doesn't matter. So instead, okay, fine. Never mind. So we'll do Y to flip, right? Y to flip these. I'm going to move this down to about here just to kind of keep this about the same look. And then I'm going to go 17, 16, is it 15, 14, 13? Okay. 15, 14, 13, 11, 10, and 9. 10 and 9 of the prom. That's pretty funny actually. All right, and then we'll go ahead and move this up. Put this roughly to there. All right, and then over on this side, so let's see. So 27, I'm gonna put over here, and oh, you know what? I am gonna do this a little funky. I'm gonna put this back to the dip 28. Prom slash EEPROM for MC-10 ROM dual socket. Okay, I'm having a little bit of change of thought. I don't know what I'm doing. I'm I'm going back and forth on what I'm doing. All right, let's just. I'm going to wire this up as the 24 pin because that's what most people will probably have anyway. And then I want these out of my. See, I wish I could like just temporarily turn off the hidden text, but whatever. I wonder if there is a way now. Okay, so pin 20. I'm going to move this up here. It's still the enable. 22, I wonder. One of these is the chip enable and the other, okay. I'm just going to assume that's the chip enable. And then this is supposed to be 21, 18, 19, 22, and 23. And then 1, 2, 8. 1 on A7. 2, 3, 4, 5, 6, 7, 8. 8 kilobyte. Okay, 8 kilobit by 8-bit ROM. Okay. Yep. Okay. I follow what you're saying. Which, yeah, I guess this makes sense. Well, it doesn't make as much sense. But, yeah. So this should be 20. 21, 18, 19, 22, 23, 1, 2, 3, 4, 5, 6, 7. Oh, this is supposed to be 8. VPP doesn't exist in this one. Let's just move these all down a little bit. All right. And then ground. Okay. All right. Yeah, I think you're right. So I think it's pin 22 of the 28 pin package, which shoot. It was right the other way. Wait, I changed it. Yeah. It was pin 22 of this package, which it makes sense to me that this chip would have an output enable instead of a chip enable because it's a masked ROM. I mean, it could still have a chip enable, but it's less necessary, right? And so you would, if you're only going to have one output enable or one enable signal, it's going to be output enable. So it should have been the output enable of the 20. So that was 22. I changed it to 20. We deleted the other one. I'm moving on now. Okay. So then did all of that. So we can come over here and say MB8 3. So we can just add this in. Yeah, I'm drawing this a little bit different from what they did because this bus can come down here and just extend on for a really long time. And then if I take these address lines and attach them to here, and these address lines and attach them to here, except I did that wrong again. There we go. Huh. What did I mess up? Ah, off by 1. Nice. There. Okay. So I've got that. And then how are we going to get the data bus over there? I mean, I guess something like this, right? And the whole reason I drew these this way so I could duplicate this. All right, that's fine. So 2 things we're going to do. I'm going to grab this in G and, oh, what are you doing? Oh my God. There we go. All right. And then I want to move these over by 1. And then move these back a little bit. So I'm using G, not move, so that it's like it's drag. It more intelligently drags the polygons around. So we can do that. And I'm still thinking I want to color code this, but not tonight. I think we are going to essentially copy this idea. I do like color coding buses, and I remember last time I tried to do it on stream, I couldn't remember how. Oh, I'm going to give it a shot real quick because I think I know why I couldn't do it before. So what I want to do here is I want to copy all of this because it's basically the same thing as right here, except this should be C18. And this is U3. Yes, it is. So this is going to go down here. I'll come back to the bus coloring thing in a minute. Let's finish up because this isn't actually, we're almost done with other than the enable signal, we're almost done with this. So what I was going to do here is just do let's do text, and we'll say TMS 2564JL, like this. And then I'm going to, ooh, is this going to work? Can I do, let's see, 1? I don't know. Is this going to work? And then can I hit insert? No. Shoot. Let me try one other thought I have. Label text. Nah, those are too different. Yeah, okay. I feel like, okay, so what if I just did this? How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24. I'm going to try this. I just feel like this is going to be faster than editing this stuff. Oh, James, come on, man. Get with the times. There's a property editor now. Don't be so lame. Okay. That's still going to be a pain in the butt. Because this is so much faster. Twelve, 13, 14, 15, 16, 17, 18, 19, and then on these, I'm going to select the rest of these. And we're going to do Control H. We're going to change 1 to 2 in the selection. So I can just do 20, 1, 2, and 3. Yeah. It's just, I thought I would just do it in here, but it was going to take too many clicks. So that was faster. Wow. Really? Whatever. The numbers are there now. They're out of order because of the way I pasted them. Isn't that funny? Whatever. So now I realize this whole thing needs to come over here because I need room to put my numbers. So we're going to click and move. Click and so 19, 18, 17, 16, 19, 18, 17, 16, 15, nope. Nope, 14 does not go there. Nice try, buddy. 16, 15. So one thing that is new that I totally recognize now is when I'm moving these text labels, they're on a completely different grid than everything else. Like right now, the grid down here is showing up as 50 made up units. And so if I move this text, it's on a different, it's not on the 50 grid. It's like on, well, I don't even know what it's on. How are you supposed to know? Yeah, because like, whoa, but no, that's not how I expected that to work. So 19, 18, 17, 16, 15, 13, 12, and 11. All right, and then, ooh, there is a 27 and a 2. So let's just put the 2 here for the moment. The 1 here, I think what I'm just going to do is I'm just going to add a, I'm just going to say 1, 1, 20, 2, 2, 5 volts. And then down here, I'm going to say 2, 27 to ground. Let's make that 2 lines. I don't know. I don't know. You know what's funny to me is I've probably said this before. I can always tell when a software person starts using KiCad because they always want to know how to automate everything. And it's like, I think software developers they just have an aversion to using the mouse. They just hate clicking anything. Sorry. I guess anyone could be that way. It just seems like I don't know. Okay. Uh, 23, 20, 21, 24, then 25, which we didn't make. Okay, I'll come back to that in a minute. So 3 goes to 1. And then 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9, and then, oh, it is 10. Okay, I didn't look far enough ahead. 10. I don't like that. I'm not going to get into it. All right, this is going to come up to here, which is going to end up on 20. And then we need to make one for here and here, which I will just use the text property now, or the property panel. Well, I guess the text property in the property panel. There. Neat. Oh, this is capacitor C18. Oh, I forgot. When I'm doing these, I should have done this a long time ago. One thing I like when we're doing bit preserve stuff, because we're replicating annotations, I usually, well, what I've learned, not usually, because it's only the second time since version 7, is I turn off the automatic annotation, because I want parts to come in with question marks so that when we run ERC, ERC will catch it and say, hey, you forgot to label this. I mean, we should also end up with, you have multiple C1s or C2s or whatever, but it's just a better way to, catch that kind of thing. Cool. All right. So we got that much done. I'm happy with that. Surprised it took this long, but that's because I get distracted. All right. So we've got the processor, a latch, and the ROM, and a reset circuit. Cool. Automate all the things. The mouse is sin. Yeah. I get it. I do. I just, it's just funny to me. I can always, like I said, I can always tell by the questions. It's like, okay, this is somebody that's normally used to writing software, and now they're trying to use KiCad, and because it doesn't work like a text editor, it's very frustrating, and I get that. So, all right. Well, I think I'm going to stop here for now. That gets us pretty far. I sort of think a good starting point next time would be to go ahead and just do this. Let's just get this edge connector done, because that should be an easy one. Or maybe we'll save that for like the end of next time. But then let's see. So next we'll add a 174, a 245. Yeah, actually, I think what my plan for next time will be is let's finish this kind of L part. So we'll do those two logic chips. I forgot what a 174 is. Is that a latch? A 245 is a buffer. And then there's some 32 gates. What are these? Exclusive ORs. So we'll do some of these gates in this 155. So yeah, so I think next time we'll probably get that whole section done. And that'll actually be really good. That'll look good. So he uses a mouse instead of HJK. Although, I don't know. I mean, I converted to using KiCad in 2015, and compared to Eagle, which was what I used before, and then before that I used like really expensive CAD tools, which I won't even compare to, and the stuff I was doing in them was pointless, and so it's not even like a valid compare. But the hotkeys in KiCad, in my opinion, are really darn good. And well, all right, let me back up. In KiCad 5, the hotkey system was so good. I loved it because it was hover sensitive. So you could hover over things and it would react to whatever you press. You didn't have to click something. In 6, that changed, which is unfortunate, but it was still really nice. Or it's still really nice. It used to be really nice that you could just hover over. Anyway, never mind. I'm just babbling. Forget me. Forget what I'm saying. All right. Come on. Okay. So let's do ignoring sim. What did I just type? Simlib table, because that gets recreated on each. That gets recreated each time KiCad runs, I think. I've been noticing as I go through some of the other bit preserve projects that people have submitted that there's a lot of extraneous files. So I'm trying to improve the git ignore. So that should be, yep. CPU plus latch plus ROM. CPU plus latch. Yeah, that's all I'm going to put there. That works for me. Okay, cool. By the way, if you didn't know, there is a new Workbench Wednesdays video out. Came out yesterday. It is hands-on. It is my hands. Okay, that's weird. It's a hands-on with the Nordic NRF 7002. Basically their chip, but the development kit that the chip comes on. That is their Wi-Fi 6 chip that does 2.4 and 5 gigahertz. And so I played around with that, and then on Monday, PCBs came back for a project involving that specific chip. I'm going to make a Wi-Fi enabled LED detector so that I can attach this little box to things like my dehumidifier and get a MQTT message whenever it's full. So I'll be working on that in terms of a project. I don't actually know why those files aren't already in the symbol in the git ignore, except that the git ignore is probably from KiCad 4. So that might be why. Whoops. So anyway. So, all right. Hey, Kurt, welcome to the stream. I don't think I said hello, even though I'm about to say goodbye. So, all right, guys, thanks for hanging out. This was fun. Go check out the new video. Is that project going to be streamed? No, that won't be streamed. Maybe if I do some coding work on it, I'll stream that. But that'll be an Element 14 video. So that'll be on the same channel that the video I just posted, which if that didn't go through chat, then I give up on YouTube. So, all right. Also, don't forget, if you guys aren't in it, we do have a Discord, since as a streamer, or I should say now, I should just go one level up. As somebody doing anything on the internet, I'm now legally required to have a Discord server. So, yeah. So, again, thanks for hanging out. If you're going to FOSDEM this weekend, learn some cool stuff. Can't wait to see all of the social media posts on that. I'm not going. I'm sad. So, all right. Thanks, everybody. It was great to talk to you. Take care. Catch you later. Bye. Oh, please make sure you find time to do something you enjoy doing and then share it with other people. I'm going to find a better way to sign out, but I want to say that just in better words. Bye.